Hey, hello guys, welcome back to the channel Software Brains. We are back with another new video. Hope you all are doing good and learning well. If you are new to the channel and haven't subscribed yet, please do subscribe and support us so that we could make more and more interesting and useful content for you. So without wasting time, let's dive into the video. So in this video, we are back with another new video on the most important coding questions. So in this video, we will be discussing a program on happy number. So let's see what an happy number is and how we are going to solve that program. So happy number program. So an happy number is nothing but any positive number greater than 0 is called happy number if we repeatedly replace the number by sum of square of its digits till the final result becomes 1. So it's so simple, like you will be given a number, you have to take the square of each digit of the number and add up add up to a sum, and if the total sum is equal to 1, then it becomes a happy number, and you need to add the digits sum until the digits of the sum is either 1 or it could be 1 or it may not be equal to 1, and there would be scenarios like those numbers, the sum of the numbers would be repeating. So let's see how we can solve this happy number. So to give you a brief analysis of happy number, I have come up with few examples so that you could get some idea how you are going to solve this problem. So let us consider 19. 19 has two digits, 1 and 9. So I am squaring up 1 and 9. That is 1 square is 1 and 9 square is 81. My total is 82. Now 82 is a total which is not equal to 1, right? So I am gonna do the same process again. So 8 square, 2 square, which is 68. Now it is also not equal to 1. Now again I am gonna square my digits, 6 square, 8 square, that is 100. Now it is also not equal to 1. Now again I am gonna square each of my digit in the number. So I have 3 digits, 1, 0, 0. When I square up and add the sum is equal to 1. So my sum is equal to 1, hence the 19 is an happy number. Similarly, we have another example, 31. 31 has 3 and 1. I have added up to 10. Now again 10 is not equal to 1. I would repeat the same process and I have got my sum as 1. Hence 31 is a happy number. So think how you are going to solve this programmatically. It is so simple. Just you need to apply your own logic. So let's see how we are going to solve this problem. So I have written the code in Java. So I have written my own logic. There could be a number of possibilities to solve a program. So first let us see how we are going to solve this problem. So as you might all aware, like how we are going to frame a program in Java, right? I have took my class Software Brains and have main method in it. Now I am reading my input using the scanner. So now enter a number is displayed on the prompt screen. I would enter my number and I am storing it in the num variable. I have also took two variables, remainder and num, so which gonna be used in the program. So now the actual and the crucial logic begins here. So what we have to check? We have been given number and we have to extract each and every single digit of the number. So let's see the inner while loop first. So what I am doing in the inner while loop, until my given number, which is suppose we have took 31 as a number. So I am doing until 31 is greater than 0, I would be repeating my while loop. So what I have written in my while loop, the same logic which we discussed earlier, that is how to find the last digit of the number and how to find the remainder and quotient. So how to find the last digit of the number? So number mod 10 would give us the single last digit, and I am storing it in the remainder variable which I have declared earlier. I have also declared sum and initialized it to 0. So in the sum I am doing sum is equal to sum plus the remainder square, that is remainder into remainder, that is if I get here 30 from 31 I would be getting 1. So I am doing sum is equal to sum plus 1 square, that is 1 into 1. So now again I am finding the quotient. So now I would get 3 as my quotient. My number would be 3. Now 3 is greater than 0. Now 3 mod 10 would give you 3. Now again sum is equal to sum plus 3 into 3, that is 3 square. Now my number, that is 3 divided by 10 would give you 0. Now my number is not greater than 0. It would come out of the loop. Now I am assigning my sum, which is the square of sum of the digits, that is 1 square and 3 square, and I am storing that sum and in sum variable, and now I am assigning that sum to num variable. Okay, and I am making my sum variable 0 so that it could be used in the upcoming iterations. So now we are going to the outer while loop. How many times we need to repeat this process? We should find this process until our sum is equal to 1, right? So I would let you know why I am taking my given number should be, my num, which is our total sum, should be greater than 9. So until our total sum is greater than 9. See, sum, why I am taking 9 here means we would be having sum is equal to we would be having sum is equal to 82, 68, all are 2 digits until we are getting a single digit number. Until we are getting a sum of single digit number, that many times I would be repeating my while loop. So inside my while loop, I would be repeating my logic until our sum. Here num is gonna be sum. Why? Because we are assigning the sum to num, right? So until we are finding a single digit sum, we would be repeating this logic, right? So whenever this num is less than 9, it would be coming out of this loop. Now we are checking whether our num, our total sum is equal to 1. That means if it is equal to 1, it is a happy number, else not happy number. Guys, this is so simple logic. Just you need to understand what you are going to do with the digit sum. You would be extracting each single digit here, and you would be finding the square of square sum. You would be squaring up your digit which you have extracted and adding up to sum, and you are checking whether the sum is greater than 9. If it is greater than 9, again you have to find the same process for that sum. So you need to find until you are getting a sum which is less than 9. So you need to find the single digit number sum. So let us consider another example where our number is 25. So I am doing the same set of steps for this 25, like 2 square, 5 square, 29, and 29 is not equal to 1. Hence I would be doing the same process. I would next 4 and 9 square, 81, 85. 85 is again 8 square plus 5 square, that is 89. Again 89, 8 square plus 9 square, that is 145. Again 1 square plus 4 square plus 5 square, that is 42. Again 42 is 4 square, 16, 2 square 4, 20. Now I am doing 2 square plus 0 square, that is equal to 4. So finally I have found a single digit sum, and that single digit is not equal to 1. So if you see, previously we have written a program and we have put the while condition where our sum, which is the num, which is the sum, is our number should be greater than 9. That means you are taking the sum of the square of the digits, and that sum should be always a 2-digit number. If you are at the time you are finding the single digit sum, there itself you are coming out of the while loop and checking whether the sum is equal to 1 or not. So hence, but you could also solve these scenarios, in another way. So to brief you that how you are going to solve, see, we are stopping our program here. Now there could be possibility that you should find the cyclic behavior of this number, like see 4. Now 4 again is 0 square plus 4 square, which is again 16. Again 16 is not equal to 1. We will be doing the same process. We would be getting 37. 37 is again the squaring up and finding its digit sum 58. Now 58 is again doing, we would be getting 89. If you see here 89, the sum 89 is already repeated. So now you are getting a cyclic series of numbers. So that means at any cost or at any part of the series you won't find your sum as 1. So what you are going to do, that means it could be a continuous process, and at any cost you are not going to find the sum. Hence it is a not happy number, unhappy number. So but according to our logic we are stopping up here. And if you want to find the cyclic behavior also, then you could consider the following logic. See, same program which I have explained you earlier, I have done some modifications. So in this program I have took a set. So set is nothing but unique. It would store the unit characters, unit integers or unit values. That means it won't allow the duplicate values to be stored in it. So it is a concept of collections where we're going to have maps, sets and list. So list will allow you to store duplicate values, but set won't allow you to store duplicate values. So same, I am reading a number, I am storing it in the number. Now earlier in the while loop we checked that our sum should be greater than 9, but here I am doing whenever we will be doing the sum and we will be finding the sum, and we would be assigning to the same number, and what we are doing in the outer while loop, each time I am finding the final sum, I am adding that sum to my set, so that my set would contain all the sums which we have obtained. So see here, I am adding while digits dot add of number. Digits is the set which I have declared, and I am adding my sum which is obtained here, our result which we are stored in the number here. So we are adding them. So if it gets added to the set, it would return true. If it fails to add to this set, that means that number is already existing in this set. So the moment you find a duplicate number, the while loop breaks and you would be coming out of this while loop, and again you would be checking the total number or the total result which is equal to 1. If it is equal to 1, it is a happy number, else unhappy number. I hope you have understood this problem. If you still have any doubts, please do comment below the video. We would be giving more and more analysis and explanations in our upcoming videos. So thanks for watching. Please do subscribe and click on the bell icon to be notified on each and every update from Software Brains. So bye.